When it comes to building the future of AI, there are really two big competing ideas on how to get it done. Today, we're going to break them down. Welcome to The Explainer. So let's just jump right in with the big question that's really shaping everything right now. As AI gets more and more powerful, we have to make a choice about how we actually build this stuff. Is the answer to try and build a whole new world for AI from scratch? Create the basic rules, the protocols, the marketplaces where all these different AIs can compete with each other, and may the best AI win. Or is it better to just focus our efforts on real, practical things that can help us right now? Using AI to tackle some of our most urgent, real-world problems? That's what we're exploring today, these two parallel paths in AI development. The protocol versus the practice. We're going to look at a project that's trying to build a new economy for AI, and another one that's using AI to save lives by fighting fires from orbit. Okay, first up, let's talk about the protocol approach. We're diving deep into a project that wants to build an entire economy for AI. It's called BitTensor, and its goal is, well, it's incredibly ambitious. So what's the big idea here? Well, BitTensor actually models itself after Bitcoin. The dream is to create this decentralized, totally open market where anybody can bring an AI model to the table and get rewarded for how good it is. And this is where it starts to get really interesting. See, BitTensor borrows that core economic idea from Bitcoin, a fixed supply of 21 million tokens, but then it builds this way more complex ecosystem on top. Instead of just miners, it has 4 completely different roles. Let me give you a quick breakdown of how this all fits together. First, you've got subnet creators. They set up these little markets for specific AI tasks. Then you have the miners who actually submit their AI models to compete. Next up are validators, who are basically the referees. They score the models. And last, you have delegators who bet their own tokens on the validators they think are the best judges. Now, on paper, it's a really brilliant design, right? But how does it actually work in the real world? Well, we can look at the on-chain data, which is just the public record of everything happening on the network. And when you look at that data, it tells a pretty stark story. In your average BitTensor marketplace or subnet, the top 1% of people control a whopping 90% of all the staked tokens. This chart really shows you what that looks like. Every bar here is a different AI marketplace. And as you can see, in pretty much all of them, a tiny little group holds most of the economic power. Kind of raises some questions about that whole decentralization goal, doesn't it? This massive concentration of wealth leads to a really crucial question about how the system is actually incentivized. Is this network truly rewarding the best AI models, or is it just making the rich richer? These heat maps tell the whole story. The redder the color, the stronger the connection. And what we see for both the judges and the AI model creators is that the link between how much money you have, your stake, and the rewards you get is deep red. It's a super strong connection. But the link between the actual performance of your AI and your rewards, much weaker. So the big takeaway here is that in this system, having more money is a much better way to earn rewards than actually having a better AI. All right, now let's completely shift gears. We're going from the abstract world of protocols and economies to a very real life or death problem. Wildfires are getting worse every year, and spotting them early is absolutely everything. So a team of researchers decided to see if they could use AI to detect these wildfires from satellite images. Instead of designing a whole new economy, their goal was simple. Just build a tool that could spot fires faster and better than anything we have today. Now here's the really clever part. Their big breakthrough wasn't some super complex new algorithm. It was about using better data. They switched to a more advanced satellite that didn't just give them clearer pictures. It gave them data our eyes can't even see, things like vegetation health or the intensity of a burn. It gave the AI way more clues to work with. And that single decision to just use better data led them on this really fascinating journey, and it resulted in a pretty amazing breakthrough. Okay, check out how they did it. They started with a pretty simple model, using just regular pictures, and got about 70% accuracy. Yeah, not bad. Then, just by adding that extra data from the better satellite, the accuracy jumped to almost 79%. And with one last simple little tweak to the model, it soared to over 95% accuracy. The final result was a model that was not just accurate, but also really reliable. This chart here, it's called an ROC curve, and all it's really showing is that the AI got fantastic at spotting real fires, while at the same time not raising a bunch of false alarms. That's exactly what you want in an early warning system. So, of course, the team started wondering, if our simple model did this well, what would a bigger, more powerful, state-of-the-art AI do? So they decided to try a much more complicated model called a Resonant 50. But in this wild twist, the more complex model was actually way worse. Its accuracy dropped all the way down to 64%. The bigger algorithm wasn't better. It just kind of got confused by all the data. The simple model, fed with the right information, was the clear winner. So what do these two completely different stories from the frontiers of AI tell us about how we should be building this incredible technology? While on one hand, you've got the protocol approach with BitTensor, a really elegant system on paper that in the real world ended up rewarding wealth more than performance. And on the other hand, you have the practical approach with the wildfire detector, a focused problem where the key to success wasn't some complex system, but just finding the right data. And this really leaves us with a final question. As we build this AI-powered future, where should we be putting our energy? Should we be focusing more on perfecting the grand, elegant rules of the game? Or should we be focused on building better, more practical tools to play it? What do you think?